Hello. Alright, so we're going to get started with going through the introduction module of how to think like a computer scientist. This will be going over basically Python programming and how to problem solve using the Python programming language. So in the general introduction, we'll be going over and reviewing the following sections: the way of the program, algorithms, the Python programming language, executing Python in this book, more about programs, looking into what is debugging, syntax errors, runtime errors, semantic errors, experimental debugging, formal and natural languages, a typical first program, and for the comments, glossary, and exercises. We can also complete some review at the end of each section and quiz each other and prep for upcoming classes, courses, or projects. Let's begin. The way of the program. The goal of this online book is to teach you to think like a computer scientist. This way of thinking combines some of the best features of mathematics, engineering, and natural science. Like mathematicians, computer scientists use formal languages to denote ideas, specifically computation. If you think about Python, it'll probably say it in one of the later modules, but it's a lot like a very complex calculator. It's incredible for setting up built-in formulas where a user can then put in measurements or values that they gather from their research or data collection, and it will pop out the resulting value that they need without having to go through a formula and plug it in. It would be built into the Python program that is, or utility that is devised for their use. So it really helps to increase productivity levels in a workplace environment. People can get all the menial data base level data analytic database management tasks out of the way, and they can dedicate more time to creative exploration or devising of scenarios where they can further collect more information. And then also to present that information. Like engineers, they design things, assembling components into systems and evaluating trade-offs among alternatives. Like scientists, they observe the behavior of complex systems, form hypotheses, and test predictions. The single most important skill for a computer scientist is problem solving. Problem solving means the ability to formulate problems, think creatively about solutions, and express a solution clearly and accurately. As it turns out, the process of learning to program is an excellent opportunity to practice problem-solving skills. That's why this chapter is called The Way of the Program. On one level, you will be learning to program, a useful skill by itself. On another level, you will use programming as a means to an end. As we go along, that end will become clearer. Another thing I want to note about the platform where this book is being hosted, Runestone Academy. They also provide a lot of other online modules for other programming languages. So going into the fall semester of this year, 2022, we're going to see if we can also include some Java programming and HTML or CSS. If you have any further suggestions, feel free to email xillliman@gmail.com. The email address will be listed in the description below. When this is posted later, yeah. I'm trying to see where the next button is, but here we go. Right. So to further demonstrate what I was explaining before about the different open computer science textbooks on Runestone Academy, here's their entire library of online courses that they provide. So advanced placement, computer science textbooks, that's for introducing high school students into the field of computer science. There's algebra textbooks, which are very helpful for getting into data science and many of those applications. There's Java, there's Runestone Bluebook, and algorithms, data structures. But the one we'll be getting into, as you can see here, we have the Intro to Computer Science textbooks. The one we'll be doing is the fourth item down on the list, How to Think Like a Computer Scientist. Wait, that one's for C++. There's a different one for Python. I haven't gone through the whole list yet, but yeah, there's a lot here. So that would be interesting to go through those later. Just go back to the course we're already going through. So second section of this chapter is about algorithms. If problem solving is a central part of computer science, then the solutions that you create through the problem solving process are also important. In computer science, we refer to these solutions as algorithms. An algorithm is a step-by-step list of instructions that, if followed exactly, will solve the problem under consideration. Our goal in computer science is to take a problem and develop an algorithm that can serve as a general solution. Once we have a solution, we can use our computer to automate the execution. As noted above, programming is a skill that allows the computer scientist to take an algorithm and represent it in a notation, a program that can be followed by a computer. These programs are written in programming languages. So another way of thinking about algorithms is like an engineer will be given a task that needs to be completed in a factory as an assembly line, and so different machines automate specific steps of creating a product. And so in an algorithm, it looks like a mathematical formula been written out, but each value or object in that formula is equitable to a machine on an assembly line that performs a specific movement or task that altogether automates the production of a product from raw material. So the raw material in the instance of Python programming languages would be data, information. So what is the most important skill for a computer scientist? Is it to think like a computer, to be able to write code really well, to be able to solve problems, to be really good at math? In the previous section, we already talked about problem solving being very important. Computer scientists are all about solving problems. We use computers to automate solutions to problems and to do things faster and more accurately than we can do by hand or manually. An algorithm is a solution to a problem that can be solved by a computer. A step-by-step list of instructions that, if followed exactly, will solve the problem under consideration. A series of instructions implemented in a programming language, or a special kind of notation used by computer scientists. So we already went through in this section of how an algorithm is a step-by-step list of instructions that, if followed exactly, will solve the problem under consideration. So another way to think of algorithms is to think of them like recipes. They must be followed exactly, and they must be clear and unambiguous, and they must reach a natural conclusion. And, you know, but then we can think of the computer hosting that algorithm as a line cook that is just recreating a recipe presented to them by an in-house chef. Next section will be going over an overview of the Python programming language. The programming language you'll be learning is Python. Python is an example of a high-level language. Other high-level languages you might have heard of are C++, PHP, and Java. As you might infer from the name high-level language, there are also low-level languages, sometimes referred to as machine languages or assembly languages. So if you think of this on like the OSI model of layers, a high-level language would probably equate to like the application sublayers of programming languages, and then low-level languages would be closer to the physical and data link layers of that model. Machine language is the encoding of instructions in binary so that they can be directly executed by the computer. Assembly language uses a slightly easier format to refer to the low-level instructions. Loosely speaking, computers can only execute programs written in low-level languages. To be exact, computers can actually only execute programs written in machine language. Thus, programs written in high-level language, and even those in assembly language, have to be processed before they can run. This extra processing takes some time, which is a small disadvantage of high-level languages. However, the advantages to high-level languages are enormous. First, it is much easier to program in a high-level language. Programs written in a high-level language take less time to write, they are shorter and easier to read, and they are more likely to be correct. Second, high-level languages are portable, meaning that they can run on different kinds of computers with few or no modification. So that makes them very versatile. And really is helpful because of how many different devices and operating systems that we will circulate through in a modern workplace in the typical workday. Low-level programs can run on only one kind of computer and have to be rewritten to run on another. So due to these advantages, and another thing to note about those low-level programs is that they convert in different ways according to the operating system. So that's like on the very physical, hardware of any computing device. You use those low-level languages, and then you start to lay operating systems on top of those, and they each operate with their own programming system and have their own syntax and their own ecosystem that is developed with its different functions. Due to these advantages, almost all programs are written in high-level languages. Low-level languages are used only for a few specialized applications. Two kinds of programs process high-level languages into low-level languages: interpreters and compilers. An interpreter reads a high-level program and executes it, meaning that it does what the program says. It processes the program a little at a time. Alternately reading lines and performing computations. So here we have a little graphic. If you start with the source code, goes through an interpreter application, and it converts that source code in a high-level language into output that the system can then process. The compiler reads the program and translates it completely before the program starts running. In this case, a high-level program is called the source code. I was just thinking if I explained that right. I think I did. So an interpreter reads a high-level program. I'm just going to go over it again just in case. An interpreter reads a high-level program and executes it, meaning that it does what the program says. It processes the program a little at a time, alternately reading lines and performing computation. So actually what an interpreter is the program that facilitates the actual operation of the function that is written into the code of a high-level language. A compiler reads the program and translates it completely before the program starts running. In this case, the high-level program is called the source code, and the translated program is called the object code, or the executable. Once the program is compiled, you can execute it repeatedly without further translation. Many modern languages use both processes. They are first compiled into a lower-level language called bytecode, and then interpreted by a program called a virtual machine. Python uses both processes, but because of the way the programmers interact with it, it is usually considered an interpreted language. There are two ways to use the Python interpreter: shell mode and program mode. In shell mode, you type Python expressions into the Python shell, and the interpreter immediately shows the result. The example here shows Python shell at work. So we'll be working with a lot of these throughout the course of the book. It's really fun. We love exercises, practice and experiment, with different ways to go about solving a problem or creating a function, an algorithm that can be executed through the shell. So these sequence of 3 right-facing carets, or greater than symbols, kind of like an ellipses, but using those symbols, those are called the Python prompt. The interpreter uses the prompt to indicate that it is ready for instructions. So if we type, looking at this, here the prompt leads up to where we type 2 plus 3. And this mathematical function for addition is already built into the Python programming shell. So it will interpret that instruction and it will evaluate that expression and give us back on the next line the sum or the answer, which is 5. On the next line, it will present a new prompt, basically communicating that it completed the previous prompt, which was treated as a query. It gave sufficient answer, and it's ready for more input. As we go through the review of later modules, we'll see that there's ways to modify the output, how it's presented, or how it's worded, and that kind of thing. Another modification is like conversions into different mathematical systems, like from Celsius to Fahrenheit, pounds to kilograms, those kind of things, which is really, really helpful. Working directly in the interpreter is convenient for testing short bits of code because you get immediate feedback. Think of it as scratch paper, and you can use that to help you work out problems. Alternatively, you can write an entire program by placing lines of Python instructions in a file and then use the interpreter to execute the contents of the file as a whole. Such a file is often refer to as source code. For example, we used a text editor to create a source code file named, for example, as provided here, firstprogram.py with the following contents. So we instruct the Python shell to print the phrase my first program as two numbers, 2 and 3, and then we specify what the mathematical operation actually is with values/objects that are readable by the Python interpreter's executable code. And then it will provide the answer as it did before. By convention, files that contain Python programs have names that end with .py. Following this convention will help your operating system and other programs identify a file as containing Python code. So here we see the output from that example we just went through. These examples show Python being run from a Unix command line. In other developmental environments, the details of executing programs may differ. Also, most programs are more interesting than this one. And more information. Here are links, which I can place in the video description when we upload this session to YouTube later, where you can download Python and install it onto your Windows or your Mac, or if you use Linux. I think there are some Linux distributions though that already have a built-in Python program. And then this is a reference video. This will be really interesting to go through later. That shows details about Python shell and source code. On my computer, I already have that program built in. It's really fun. It gives you a lot more liberty and freedom than the Python shells route this particular online book provide for seeing exercises. So it's really great for looking into what typical Python projects entail, and then researching different solutions that other computer scientists have provided and practicing with those, or even looking for a new way to put the language together to solve problems. And that's the thing, it's like with any human language, as we're learning it, it's really good to have those extra programs at our fingertips so that we can practice and gain more fluency. The more that you practice, the more that you challenge yourself to engage in those computing conversations, the more comfortable you're going to eventually get with compiling files and thinking creatively, so you can best express yourself in that format. Source code is another name for A, the instructions in a program stored on a file. B, the language that you are programming, in this case Python. C, the environment or tool in which you are programming. Or D, number or code that you must input at the top of each program to tell the computer how to execute your program. Yes, the source code would most likely be the instructions in a program stored in a file. The file that, or another way of wording it, the file that contains the instructions written in a high-level language is called the source code file. What is the difference between a high-level programming language and a low-level programming language? A, it is high-level if you are standing and low-level if you are sitting. B, it is high-level if you are programming for a computer and low-level if you are programming for a phone or mobile device. C, it is high-level if the program must be processed before it can run, and low-level if the computer can execute it without additional processing. Or D, it is high-level if it is easy to program. It is very short if it is low-level if it is really hard to program in, and the programs are really long. The most reasonable answer will be C. It is high-level if the program must be processed before it can run, and low-level if the computer can execute it without additional processing. Python is a high-level language, but must be interpreted into machine code, aka binary, before it can be executed. Pick the best replacements for 1 and 2 in the following sentence. When comparing compilers and interpreters, a compiler is like 1, while an interpreter is like 2. So A1 equals a process, 2 equals a function, B1 equals translating an entire book, 2 equals translating a line at a time, C1 equals software, 2 equals hardware, D1 equals object code, 2 equals byte code. Well, if we go back to where we go over the definitions of what an interpreter and compilers, we did go over how a compiler reads the program and translates it completely. Is it would be object code or byte code? So it would, the best answer here would be B. 1 equals translating an entire book, whereas 2 for interpreter is like translating a line at a time. So compilers compile the entire source code and produce object code or the executable, and interpreters execute the code line by line. So it's all right, the next section is about how we're going to execute Python throughout this online book. There's a video here. where the instructor goes into really great detail.
One of the unique features of this book is the ability for you, the reader, to interact with the Python environment as you are reading the text. In fact, there are two different ways that this can be done, and you'll see these occur over and over again as you proceed. The first way that you can interact with Python is through what is called active code. The active code interpreter is an interpreter or a program window that is built into the web environment such that we can have Python programs that will execute directly from the web browser. You can see here is an example of a very small program right in the book itself, just two print statements, but when I click the Run button, you can see that the output occurs. My first program adds the numbers 2 and 3, the value of 2 plus 3 is 5, and not only is this executing this program, but it also provides me with the ability to modify. This is an editable window, and so I can come up here and simply say, I don't want it to be 2 plus 3, I want it to be 2 plus 15, and now when I run the program, you can see that the result that gets printed is 17. Or if I decide that I want to change one of these words, this program subtracts two numbers, 2 and 3. And we could then change this to be 2 minus 3. And now when I run the program, I get -1. So we can make these changes, but as we make changes and modifications, it helps us to experiment with what we're reading about. It helps us to try new things, because we always know that we can come back and simply reload the page, and we'll be right back where we started again. So the reload button will put us back to the point that we were when we loaded the book for the first time. Any changes that you made are simply gone. But it doesn't have to be that way. You'll notice there are a couple of other buttons here, save and load. If I choose to make some changes, so for example, let's say that we want to change this to be my first program adds 3 numbers, and we'll do 2 and 3 and 5. And then here I'll say print 2 plus 3 plus 5. Now if I run this program, of course it does what you would expect. It adds the numbers together. It changed the text that was going to be printed. But now if I click the Save button, what I've done is I've saved this particular version, the last changes that I made, so that I can reload them at a later time. Let's see how this works. If I reload the page itself, now you can see that I've gone back to what I had originally. But now if I click the Load button, there's the last change that I saved. Now, this save load feature does not allow me to save multiple versions. There is no naming of files. There is no having to open a particular version. It simply saves what you had in the window and lets you reload what you recently saved. It's a very nice feature if you're doing some experimenting and you want to keep something for a short amount of time, go back to the original, and then perhaps come back to the changes that you made. The second way that we can interact with Python is through a tool called a visualizer, and we call this tool CodeLens. CodeLens allows you as the reader to step through the program statement by statement and be in complete control of how the program executes. So again, here is a CodeLens window, and you can see that there are 2 statements in this program, basically 2 prints, the same ones we had before, and there are some control buttons, and the first one says forward, and if I click on that, you'll notice that what's going to happen is it's going to execute the statement that's currently highlighted in yellow. The way that CodeLens works is that it maintains the current location in the execution sequence. That's always highlighted by yellow. Whenever you click the forward button, that statement will be executed, and the next statement that it's getting ready to perform will now be highlighted. So when I click forward, watch what happens. This statement is no longer yellow, but now the next one is, but if we look down below, we can see that the execution of the print statement has occurred. The program output is that we're going to add two numbers together. If I do forward again, we'll see that we get more output. Now this can be a very, very useful feature for you because as you're running a program, for example, in the active code environment, you only see the program execute in terms of what you get at the end. But now you have the ability to control it step by step as you go from beginning to end. And furthermore, watch what we can do. We can actually go backwards. We can undo step by step. So we can go forward step by step or backward. And if we want to, we can go all the way to the end or all the way back to the beginning. Now notice that there's a section here called variables, and nothing has really been happening there. One of the other features that CodeLens will allow us to take advantage of is as we create data, as we build new data objects in our programs, we'll be able to see those data objects appear within the CodeLens screen. Just to see that, let's go to another section of the text and let's find a CodeLens window. Here's one. Now we're not going to understand necessarily the Python here, but you're going to see what's happening. Notice here's the highlighted line. When I click forward, it says there is now a variable that's been created. It's called message. And if I click forward again, there's another variable. And if I click forward again, there's another variable. And then when I click forward again, the print occurs and I see some output. If you don't understand what a variable is, if you don't understand what's happening here in terms of assignment statements, that's okay. That will come later on. What I wanted to show you was the power of the CodeLens tool. You'll find this to be a great advantage to you, being able to both go forward and backward. Notice as I go forward, I build up the data. As I go backward, the data is removed. I have complete control over the program execution in both directions. I think you'll find that both of these tools will be extremely useful to you as you're learning Python. However, one thing that we should mention is that in the CodeLens tool, there is no ability to edit. And so you simply can execute what's there, but you can't make modifications. With respect to active code, you can make modifications, but there are limitations. You should simply know that not all of the standard Python modules have been implemented in the active code environment. And so although everything works in terms of what we want to accomplish in the text, if you're trying to use other modules that exist in standard Python, you might find that they will not run within the active code window. But more than likely, by that time, you'll be running in a more general development environment anyway. General development environment.
Right. So, as the instructor was saying, this is our active code lens that we can go through. To see how Python is reading each line of the code. So this online book provides two special ways to execute Python programs. Both techniques are designed to assist you as you learn the Python programming language. They help you increase your understanding of how Python programs work. First, you can write, modify, and execute programs using a unique active code interpreter that allows you to execute Python code right in the text itself. Although this is certainly not the way real programs are written, it provides an excellent environment for learning a programming language like Python. You can experiment with the language as you go. So it's like a little sandbox as we are prompted through different exercises, we can utilize some of the operations that we learn over review of these modules and see how it works, see where we make mistakes, and really build that familiarity and fluency with Python programming language. So I really like this instructional tool because it really helped, especially in like longer longer exercises where there's more steps or instructions that need to be interpreted by the Python program. It will, list out the output in this box here. I keep pointing with my finger. To remember to use my mouse. And we'll look into that and investigate it further when we're doing more exercises. We'll probably start doing more in the next module. This is basically just an introductory and review of how this entire format will work. So we can take a look at the active code interpreter in action. What you see depends on whether you're logged in or not. Code that you write and run is saved for all future sessions, only if you're logged in. If you're logged in, you should see a green save and run button. If you're not logged in, you see only run. In the next discussion, we will refer to both variants as the run button. If we use the Python code from the previous example and make it active, you'll see that it can be executed directly by pressing the run button. Try pressing the run or save and run button above. Now try modifying the active code program shown above. First, modify the string in the first print statement by changing the word adds to the word multiplies. Now press run. And see that the result of the program has changed. However, it still prints 5 as the answer. Modify the second print statement, changing the addition symbol to the multiplication symbol, which in Python that operation is represented by the asterisk. And press run to see the new results. So, as we're being walked through here, we go here and we do save and run. My first program multiplies two numbers, 2 and 3. It gives us the answer for adding those two numbers though. So go back and change the operation on the second print line, save and run. You see that the number changes from, the output changes from 5 to 6 on the second line. After you have run your code the first time, a load history button that was beside the run button turns into a slider. If you click on the slider location box, you can use your left and right arrow buttons to switch to other versions you ran. Alternately, you can drag the box on the slider. You can then move the slider to see a previously saved state. You can just run it by pressing run or edit and then save and run it as a latest version. In addition to active code, you can also execute Python code with the assistance of a unique visualization tool. This tool, known as CodeLens, allows you to control the step-by-step execution of a program. It also lets you see the values of all variables as they are created and modified. The following example shows CodeLens in action on the same program as we saw above. Note that in active code, the source code executes from beginning to end, and you can see the final result. In CodeLens, you can see and control the step-by-step progress. Note that the red arrow always points to the next line of code that is going to be executed. The light green arrow points to the line that was just executed. And, throughout this online book, it's going to give us those definitions for those symbols. So, have to memorize that right now. And it's an actual Python programming. Isn't going to show everything that way. So later on, we can actually just open up the Python program and begin writing stuff in there. And then another way I've seen it done is people will write in their lines of code into a rich text file, and some programs, they allow you to import that as well and convert it into that programming shell or command line as a way of saving work. Yeah. The examples in this book use a mixture of the standard Python interpreter, source code, active code, and CodeLens. You'll be able to tell which is which by looking for either the Python prompt in the case of a shell mode program, the run button for the active code, or the forward/backward buttons for CodeLens. The active code interpreter allows you to A. Save programs and reload saved programs. B. Type in Python source code. C. Execute Python code right in the text itself within the web browser. Or D. Receive a yes/no answer about whether your code is correct or not. There are multiple answers to this question. So it allows us to save and reload save programs as long as we're logged in to this learning platform. Also allows us to type in Python source code and execute Python code right in the text itself within the web browser. And I believe D as well. Okay, never mind. Not D. CodeLens allows you to A. Measure the speed of a program's execution. B. Control the step-by-step execution of a program. C. Write and execute your own Python code. Or D. Execute the Python code that is in CodeLens. Again, we can select multiple answers that will be correct. So CodeLens definitely allows us to control the step-by-step execution of the program. And execute Python code that is in CodeLens. So going back over these questions, you can and should save the contents of the active code window You are not limited to running the examples that are already there. Try adding to them and creating your own. The active code interpreter will allow you to type Python code into the text box, and then you can see it execute as the interpreter interprets and executes the source code. The second item is really important to note because later on, as we're applying a lot of the lesson material into solving the problems presented in the different exercises at the end of each chapter, there'll be an option in this shell that we'll be using where it can provide the steps to help us get into the frame of mind of how to use the different operations, syntax of putting or writing source code with the different objects to reach the final output that we are looking to receive. It's just really interesting to look into. But it's, from what I've seen, it goes over how the material in that specific lesson can be utilized to solve that problem. But there are multiple ways. Python language is very it allows for a very creative process. There are like multiple ways to put stuff together to essentially accomplish the same operation. But in the production line, mastery of Python is usually referred to as what is the most efficient code. Because looking into like bytes and data, so whatever takes up less space or is less processing time for the operating system and the machine. That's the best way to go about it. The next section is more about programs. I believe I'm just going to take a little break and then I'm going to come back and we can go over this section. Eat, hydrate.